CPU. Or if you have certain access patterns, you will burn somehow the storage. So the idea is to recycle the servers often to distribute the load. So you never have a server that is doing always CPU activity. You have a server doing always a lot of writing activity, or a lot of read activity, or network activity, or whatever. So having a large infrastructure allows you to do, to say, okay, I'm going to change the role of a server maybe every few months, every 3 months, or every 6 months, depending on the role. Then you have also location policies, because you have a lot of redundancy. This means that you don't want to have two servers that have the same role for the same application running in the same blade or running in the same rack. Okay. The architecture is designed to allow failing multiple servers due to the fact that we have a lot of servers. So here the trick is never have just two servers for one job. You have maybe 3, 4, or 5 servers doing one job. So if one of the servers fails, this is not a problem. You provide another one. But if 2 servers fail, this is, again, not a problem. You provide 2 new servers, and you have spare capacity. Then a new one is deployed. So the infrastructure detects that the server is failing. It's, let's say, stopped, and then it's being replaced by another one. You have a lot of physical servers with different capabilities, and depending on the role, you assign one type of server or another. I mean, the amount of memory, or the speed of processors, or things like that. And once the servers are running, everything is handled by Puppet. And one of the things we have is that Puppet can be disabled, but just temporarily. Process run on the server that re-enable Puppet after maybe 1 hour or something like that. The idea is that even if you break something and you can't contact the server, Puppet will start in some time and fix the thing. Okay? This can be a problem, for example, if you are doing something very specific, for example, regarding the topology or a configuration, and you don't want Puppet to come and undo your temporary change. Okay? The Booking.com MySQL architecture, well, Booking has several DCs. Actually, I just put 3 availability zones and 5 DCs. There are more DCs. There are DCs located in different places, but these are the most important. Okay. And MySQL is using asynchronous replication, controlled by a cluster of, well, actually currently 5 clusters of orchestrator, PCI. You have 3 plus 5 clusters of orchestrator. Each cluster usually has 3 orchestrator nodes. One of the nodes is active, and the other 2 are only just in case the active one fails. The backups are performed using Percona Extra Backup and Bacula. There are a set of internal tools developed by Booking during the years. And server cloning can be performed using either Extra Backup or rsync, and now we are testing the clone plugin. The MySQL version management is performed at cluster level. So you can say, okay, this cluster is running MySQL 8.0.25, and this one is running 8.0.26, for example. That also allows you to say, okay, let's go to the next version, and then the automation takes care of upgrading each and every server. Replication chains, three-tier replication topology based on semi-sync replication. A chain consists in a primary master. This is the server that gets all the writes and can be located in any availability zone. This means that the application must be able somehow to send writes to a different availability zone if needed. Okay. You have at least 2 masters on each availability zone that are connected to the primary master, and these DC masters, the bin log to avoid cross DC replication. So the idea is, on one DC we have a master, and then those masters get the binary logs, and they distribute the binary logs internally. Okay. In case of failure in the master, one of these DC masters will replace a master, and usually don't assume application load. Okay, they are just relaying the binary logs. Then you have also read replicas in each availability zone. The number of read replicas depends on the kind of application and the load. So if an application has a lot of load, maybe it has 5 or 6 or 7 or 20 read replicas. They replicate from the DC masters. Besides, you can have replicas, for example, for ODBC access and Hadoop replication and things like that. These are optional, and they depend on the role of the chain. Also, we have what we could call infrastructural servers. For example, to do backups, we have a specific servers. These servers are clone sources, for example, that are being used if you need to provision a new server. This means that, for example, provisioning a new server has no impact in. You're not going to use a read replica to provision a new server. Okay? In some cases, we have delayed replicas, and even we have replicas that are used for development. Database types. Each server has assigned a database type. The database type is stored both in the server and in the inventory. Obviously, to manage this infrastructure, it's not something that you have stored in the server. You need to store this information in a centralized inventory. And then the automation uses the database type to this that server. So the automation is able to say, okay, I'm a server of this role. This means that I need that specific configuration for MySQL because the load of the role implies that whatever. The database type only changes if there's a promotion. For example, you can replace the master and the database type. Okay. The different types are master, master, replica, a special replica, clone source, and etc. The problem, migrate from MariaDB to MySQL. Well, the first thing is it was not a thing like we don't like MariaDB. it was much more. We have maybe 80% of our infrastructure running MySQL, and maybe 20 or 15% running MariaDB. And when you version everywhere, and in this case, it made sense to migrate from to the bigger one. Critical applications, the client-facing applications were running already in MySQL, but the applications that were running MariaDB are critical because they are revenue drivers, and they have huge data sets. These applications are the equivalent logistic applications for an e-commerce, in the sense of you will not stop selling because your logistic system is not working, but if your logistic system is not working for a couple of days, this can be a disaster for an e-commerce. In a traditional e-commerce that sells stuff. In this, the applications are handling part of the advertising. Okay, so Google advertising and things like that. So this is obviously a revenue driver for the company, and these are critical in that sense. Also, one of the problems we had is the versions we were migrating do not support a direct upgrade. So we could not do an in-place upgrade, just uninstall MariaDB and install MySQL on the same server. So how can we manage the migration of a huge number of servers? The trick here is we will not migrate at all. What we did, well, if we want to upgrade a chain, the problem is that we said we control the versions at chain, and we have automation. Chain, automation, install MariaDB and try to start the database. Probably MariaDB would crash, and then it would try a couple of times, and after that, probably it would replace the server with another one. Okay, so we could not do it unless disabling automation completely, and this could be dangerous, and even it could bring some problems because automation also controls the topology, and we had to deal with the possibility of promoting a MySQL server to be the master before fully testing the application and fully testing the migration. Okay. So upgrade a chain, what can we do? We create a new chain and replicate the new chain from the old one. Replicate the MySQL chain from the MariaDB. And once we have both chains up and running, everything is fine, we do is one chain by the other. We tell the application to connect to the new chain, and we deprovision the MariaDB one. To perform the whole operation, we found that it was really very costly to transfer the data and to load the data, and then to create the clones and do everything. And then we got a special server just for the migration with 96 cores, 120 terabytes of disk, and a lot of RAM. And the idea was that this server had to be temporarily the master of the new chain. Okay, so the first migration was performed on this server, and then we used this server as the source for creating clones in the new chain. Steps. Well, the steps were we built a new MySQL chain with a primary on steroids. We prepare a dump of the data using my dumper. In parallel, we import the dump on the primary, and then we copy the data in the store. The automation allows us to create volumes and do storage cloning to make the whole operation faster using copy and write technology. After that, we have to wait for replication in the new chain to catch up with the old one. We move the reads to the new chain and check that everything is running fine. And if there's any issue, we work to fix the problem. After that, we stop replication in the primary and update the service discovery mechanism. This is the applications have a method to find which is the master on each time. So because if there's a switch of the master, the application needs to be able to find the master, but it also needs to be able to find the read replication that can also be replaced or can be increased, okay? And after that, you just decommission the MariaDB replication chain. So what we learned after all the process? Size matters. The huge databases take a long time to migrate. This can seem quite trivial, but it is not. In the sense of, it's not about the time it takes to transfer. It's about the time it takes to load the database. And it's time about the times you need to do this. Because unfortunately, the load of a new database, if the database is huge, faces a lot of problems due, for example, to the quality of the original database. So one of the things we had to do, we were not doing at the beginning, was verifying that the quality was good. This means, for example, you don't have any view or function that is not valid. For example, if the function was created by a user that has opt, then the function is there. But if you try to recreate that function on another server without the user, the creation of the function will fail. This is not a application because if the user does not exist, probably this means that the function is not being used, but it's a problem for the load of data because the load of data will fail. Okay. Also, the fact that the longer a process lasts, more easy is that something happens. Okay. So there's a network issue, there's whatever that can make can force you to have to repeat the operation. Okay. We had to move data multiple times. This means that you need to have really fast storage and you need really a fast network. In our case, we had to move the data across DCs also because we had to recreate the chains, and this also takes a long time if you have to transfer a huge amount of terabytes between DCs.
What was the network speed?
Actually, I don't know which is the network speed, the quality of the links between the DCs. It's really fast, but you need to understand that it's also running the replication and all the traffic between data centers related to the applications. So it's not a link that we could use for only for us, okay? And it's working with production data.
There's a few blog posts that tweet about this by Percona.
Yes. It was great to have a server on steroids because it made things really very easy. When we had to run my dumper, we could use really a huge amount of parallelism creating the databases. So this also helped us dealing with having to repeat the process multiple times due to the diverse issues we faced. Obvious. Use some kind of thing, either a screen or Tmax, to keep the session open. When you do a ton of creation of databases and things like that, sometimes you start a process in a session, and 10 minutes later, there's a network failure or something like that, and the connection is lost, the process dies, and then you have to start over, you have to clean up, and blah, blah, blah. And this is something we all do. I mean, to use a screen application or something like that, but it's also something that happens often that for whatever reason you are not running on a screen session, and 1 hour later you realize that you have to start over again. We used some, let's say, tricks, configuration changes to speed up the load. One was disabling performance schema, reducing durability, and reducing the number of synchronizations due to inlock writes. In some cases, we disabled binary locks completely. Once we have built a new the binary locks, and we also disabled the double write, which, by the way, doesn't have a great impact in performance, but it helps a little bit. Obviously, once the migration is done, you re-enable everything. One important thing we found is if the network is fast, compression does not help you. In some cases, it even makes things slower because you need to read and write the same data multiple times. You read the data, you then compress the data, you transfer the data compressed, you have to read the compressed data, decompress the data. So actually it's faster just read the data, transfer, and write it. Because compression, we got no real benefit from transferring the data compressed. We also had problems due to the fact that MariaDB and MySQL behaviors were different. Problems, for example, related to the fact that MySQL requires that all the parts of a primary key not to be null, and MariaDB supports this. So we had to change this in the original database. Also, the explicit defaults for timestamp, we had to change this. This is a parameter, you change it, and that's it. Previously to the migration, you have to validate the structure of the database. You have to validate that you don't have invalid views, you don't have invalid procedures, missing users, or missing objects. Missing users can affect the validity of views and functions, And missing objects can affect the validity of views. So for example, you can have a view, it's a table that does not exist, the view is in an invalid state, and when you try to load the data, the creation fails.
I may have not understood, but which version?
So that we upgraded to 8. Okay.
Yeah, because on the slide you said utilization, I think,
Yes, actually, it makes really faster. And lessons learned. Last but not least, the development support is required. In some occasions, we found problems that we were not able to really identify, and we had to ask the application, what's happening here? Is it okay with this index situation and things like that? Okay. They also helped us by patching the application to support the differences between MariaDB and MySQL, and in some cases, they also helped and thus making the process faster. Okay, and I speak too fast, so that's all.
I have a question with your comment about compression. What data were you compressing and trying to ship? Was it the actual raw files, or was it MySQL dumps, or?
We were compressing using the MySQL, the MyDumper dumps.
Okay, so when you say it didn't improve performance, were you streaming that, like with a gzip pipe out to a netcat? Or were you trying to compress it, say it was a file?
The problem with MyDumper is that you can't stream, you can't backup and stream at the same time, because MyDumper generates multiple files in parallel. So it's well, I think the new version can do this, but at that, MyDumper. MyDumper is a utility that allows you to perform dumps in parallel.
Because I know with MySQL, pipe it out to gzip.
Yes, yes, but the
Then you can uncompress it. So
MySQL dump does it a single thread. MyDumper is multi-threaded. Yeah. So it creates multiple files.
You can write gzip directly. Is it one thread per table, or is it one thread, multiple threads per table?
multiple threads per table is able to do it.
Depends if there's a primary key or not. Like
Yes.
if you got primary key, so we can do say a range of primary keys. Thread with no range.
So the problem is that we had to store the compressed backup locally, and then
What you can also do is, because allows to write gzip directly, SQL files.
Yes, yes.
gzip, you can do that on the target and then restore from there.
Yes,
With my loader and compressing as well. So that.
can do this. For example, if you mount the volumes from one server to the other, actually we did, in some cases we did this, because we used, this is a short version, we used different methods. So in some cases, what we did was, if the storage was, it depends, because we have different types of hardware, and in some cases we have iSCSI, and what we did in some cases was unplug the iSCSI from one server, plug into the other, perform the operation locally, and after that move the server. This way, a bit of round trips in the network, because You can do that. You can do that across the sea, of course. I never tested iSCSI across the sea. It would be funny in any case. Tell me.
Did you investigate in the MySQL shell dump and load utility that can load and dump at the same time?
We didn't.
It's a logical dump, yeah?
Okay, so you can use MySQL shell with
We did not test that.
It's just a question.
Yes, yes, we did not.
And also for people that want to know that you can do it. So MySQL dump, you should completely try to throw it away as fast as you can. But with MySQL shell dump and load utility, you can do dump and load in parallel, like my dumper. But also it has extra stuff. But it's a very nice challenge between the two products because one is better or faster than the other one takes over the lead and they change. So it's a very good competition for the user, I mean. But what's also nice with my number is that it can allow you to change character set when you do the load, like to go to a native before. It allows you to, if you don't have primary key, to create an invisible column that will be your primary key, so the application doesn't see any difference.
What about like
But you have a primary key.
what about like reset the identity, like MySQL dump, you know, if you have data in it?
No, here, this one is.
One of the things that you can do with my dumper, for example, now is you can create the table without indexes and then add the indexes later. So, and this can make the process faster also because,
Nice feature for the fragmentation as well.
Hmm?
Like you blogged about the fragmentation.
yes. Yes, yes.
I have a very basic question. So the MariaDB version and the MySQL version, would they be compatibility issues if you just do a MySQL?
No, the in place upgrade was not possible.
So it was always a logic, but even the logic, it just works, is it, without any?
The logical failed due to some, let's say, small differences that impact you when you are transferring several terabytes of data.
The two projects are diverging a lot, so you should not, let's say, oh, it will work. It's mostly you should think, oh, it won't work. That's two different projects.
Especially
It's like if you take Postgres and MySQL or Postgres and MariaDB, it's all not as different, I mean, but it will be like that. So there is no guarantee that it will work. And I think this is one of the reasons they have to migrate from one or the other one, because they say, okay, at a certain point it will be too many diversions
Yes.
that they need to choose.
But the replication between MariaDB and ISAP did work. Or did you run into trouble there?
We had issues with the replication. We had issues, but they were not directly related to replication, but the fact that some things that were done in MariaDB, for example, were not supported in MySQL. Things like, for example, the timestamps, the faults, and things.
I can tell you I migrated hundreds of terabytes, same project, from 10.1 to 8, no problem,
Huh.
with replication.
With replication.
Because 10.1 is actually 5.
Mhm.
Row-based replication works like a charm. Simplifies everything.
And you replicate from 5.6 to 8.
No, 10.1 to 8.
5.6 to 8.
And
Okay.
it works fine.
Okay.
No,
No
They
GTIDs.
are incompatible actually. So just you can use binlog replication.
The
It
normal
works,
one.
Right? For migration, it's fine. Like you don't want HA on your migration.
I assume you added the indexes afterwards.
Sorry?
I assume you did the data first and then the indexes.
Data first and then indexes. In the larger ones, we did this.
With the smaller ones you did this.
The smaller ones were quite quick. So actually, we used different methods. So it was not all, and even we used composite methods. So for example, to create the master on steroids, we used MyDumper. Then we used the local infrastructure cloning from the master, and in some cases we did cloning manually to speed up in terms of being able to clone to servers and things like that.
Two questions in one. So it didn't work the first time you did it. So how many times after you start? That's the first question. And like, how long did it take to do this project? Is it a 1 month project or is it a 2 years project?
It took, I would say, 3 months, 4 months to perform it. The project per se was longer, but because it was the kind of project that you discuss, we have to do, blah, blah, blah. But the execution, I think it took 3 months or 3 or 4.
But the 3 months is like once everything was ironed out, like it has been tested before, and like the DOM, import.
The problem is that we were a bit naive, and we designed the process without testing completely before. And this is why we had some of the problems we had to fix. And all the chains are similar, but are not the same. So they have differences.
Did you consider pulling the disk out of the rack, de-echoing to the other data center, putting it back?
No. No. We consider sending, using, shipping the disks across the different data centers. No, we did not. There was another option, was pigeons and USB keys.
So these servers, bare metal servers, they're not running any sort of virtual machines on them or Docker?
No.
It's just, so what was the resource utilization like of your current system? Is there a lot of wasted processing that could be optimized with?
I would say there's a lot of processing capacity not being used if not needed. So in terms of business, sometimes you sleep very well when you know that you can deal with a huge amount of load without problems.
If there was a sometimes while you were working there, like they are okay, the system is okay, but then it's like a workup or something like that, and then suddenly you see, but they need to be prepared on that. So
I mean, you know, like KVM virtualization has such little overhead, right, with Percona, and you can really, optimize your physical server by cramming in, a dozen or so virtual machines to really help optimize that workload. But
Yeah, but then what happens when that workload all of a sudden stops, and then the server starts going down?
The fact is that probably Booking will do something like this in the future. Okay.
Developer just end up spitting that for infra devices, or if the developer is creative to help now instead of thinking one variable, you can put this change because you have too much capacity.
You wanted to?
How many were busy during the migration?
No. We had CPUs, plenty of CPU, because actually the migration is not CPU intensive. Okay. The thing was that we had a lot of storage bandwidth, and once again, the server on steroids was not a server that we bought or something like that. It's a server that has a specific role in the Booking infrastructure for storage. Okay, so it was like we said, okay, can you lend me this server for a few months to perform the process? Okay, so Booking has, I don't know the number, but a few servers of this kind. I think they are used mostly to perform backups and things like that, to perform and store the backups. So we said, okay, give me one of the big storage boxes to
So
the.
how